covering 5.4, which is about indefinite integrals and the net change theorem, mostly indefinite integrals. So indefinite integral is the most general antiderivative of f. So what you do is, if you want to take the antiderivative the indefinite integral, this is what the indefinite integral is, this right here. It's this form right here. And so you find an antiderivative and you add a c to it, and that's the most general antiderivative. That's the indefinite integral. And the antiderivative means that capital F prime of x is equal to little f of x. Okay, so let me just do an example. So for example, let's say I want to take the indefinite integral of x to the third dx. Okay, notice that there's no limits here on it. So it's not a definite integral, it's an indefinite. So you find, you know that x to the fourth, when you take the derivative of x to the fourth, you're going to get 4x cubed, right? So you'll get the x cubed. So, but if we divide by 4, then when the 4 comes down, it will cancel with that one, and we'll just get x cubed. And then you add a constant to it. Okay, so that's like our capital F. This is like our little f. And then another part that we're talking about is the net change theorem. So derivative, an example here might be like velocity, or something. You know, it could be something else. But like for example, if it's velocity, then this would represent the net change in position. So if you have an object that's moving at a certain velocity and you've got the formula for the velocity, then if it moves around, then basically this right here, when you take the definite integral from a to b, from time t equals a to time t equals b, then you're going to get the displacement. Okay, so you're not going to get the total distance traveled every time. You might, but if it like for example, if it starts here and goes over wherever there, and then it backtracks some, then this quantity here is just going to give you this distance. Okay, it's not going to give you the whole, even though it traveled much further. Okay, it traveled all the way to there and then back. So that's just an example to watch out for. Okay, so let's go ahead and do some exercises. Number 1. And the first one is just verifying that you have it says just state whether the following is true or false by differentiation. So essentially, we're going to differentiate this, okay? We're going to differentiate this. And I'm going to rewrite it into a form that you can more easily differentiate it. And so instead of just writing square root, I'm going to write 1 plus x squared to the 1/2. And then you can avoid the quotient rule by rewriting this x in the numerator as x to the -1. Okay, so then I'll take the derivative of that. So it's the derivative of the first part. So you got a 1/2 coming down. To the -1/2. And so you'd reduce that by 1 power to that. And then you multiply by the derivative inside, which is 2x. And then you have this piece here, x to the -1. Okay, then you have the derivative of this times this one. So I factored the -3 all the way out, so I don't have to worry about that. So I'm just going to write 1 plus x squared to the 1/2 times the derivative of this, which is negative. So -1 comes down, so that's negative. And then -1 minus 1 is -2. So you get that. Okay, now let's see here. I got this -3 here. And I have some canceling that I can do. So this 2 is going to cancel with that. These actually cancel because this is 1 over x, this is x, so they're going to cancel. And this will just be 1 over the square root of 1 plus x squared. Okay, this right here will be 1, because this is the square root of 1 plus x squared right here, and then this is over x squared, like that. Okay, now what I'm going to do is I'm going to get a common denominator so I can combine these. So here I'm going to multiply by x squared over x squared. And here I'm going to erase this parenthesis, and I'm going to multiply by the square root of 1 plus x squared over the square root of 1 plus x squared. So just multiplying each of these by 1 to get the common denominator. Okay, so this is going to be x squared, and then these are going to be 1 plus minus 1 plus x squared. And then in the denominator we have x squared times the square root of 1 plus x squared. And now these x squareds are going to cancel, then the negative is going to cancel. And you're just going to end up with a 3 over x squared times 1 plus x squared. And that and that match up. So that the answer is true because they're the same. The derivative of that is the same as what you're taking the indefinite integral of. Okay. Number 2, find the general indefinite integral. Okay, so when you have something like this, it's a product. Taking indefinite integrals of products is that is kind of hard, actually. There's no like product rule for that. The closest thing would be integration by parts, which we will learn later, or maybe next semester, I'm not sure. But what you want to do is, it's kind of hard. It's much more complicated to take derivative of a product. I mean, to take an indefinite integral of a product, I'm sorry. So what you can do in this case, though, is you can just multiply everything out, and then that becomes much easier. So 8u times u is 8u squared. Then you have the outside ones, this is 9u, and then the inside is 8u. That's going to add up to 17u. And then the last one is plus 9. Okay, and now you have just the polynomial, which is not that bad. Okay, so this one right here, u cubed is what you look at. You just raise this by 1 power. But in order to make it so that when you take the derivative of this, you get this, you have to put a 3 underneath, because you'll have a 3 coming down. Same thing, or similarly with this one, you got to put a 2 there. And then the 9 is just 9u. Okay, make sure you use the variable that it's in. And then put a constant on the end, and you're done. Okay, so that should be the answer to number 2. Okay, let's move on to number 3. Find the general indefinite integral. Okay, so you look at cosine x, and you know that when you take the derivative of sine x, you get cosine, right? So that should work okay. That works. And then here, you're gonna have to be an x squared. If you take the derivative of x squared, you get 2x, but you want 1/2 x. So if you divide by 4, that should give it to you. And then put a constant on the end. So that would be the answer to part A. Okay, or the first part. Then the second part is to illustrate by graphing several members of the family on the same screen. So we're going to do this in GeoGebra. And so we'll put this function in, and then we'll put different. So by family, what they mean is this piece right here. What they mean is each value of C is a different member of the family. Okay, each value is a different member of the family. Okay, so let's go ahead and, so remember sin x plus x squared over 4, and then we'll add different values of c and see what we come up with. So go over here to GeoGebra, and just go to the regular calculator, and sine of x plus x squared over 4. Okay, and then I'm going to hit enter, and that locks in there. So there's one member of the family. That's just with the constant c equals 0. Okay, then let me copy that this time. I'll just copy it. So now I'll paste it there, and I'll put plus. Let's see, what are some of the values I have? Looks like multiples of 5. So it looks like -5 is in all of them. So I'll start with a -5, and that's right there. And then I'll put a +5 right there. And let's try 10 also, +10. So there's another one. You can't see it because it's too high. Now let me move that over. Let me zoom out here and move this down. And there you go. Those are 4 members of the family. So those are all antiderivatives of, they're all members of the indefinite interval of that particular function that we just did. And it looks like the second one is the answer. Okay, so there's a bunch of them right there. And so let's go back. It looks like out of the multiple choice on the homework, it looks like the second one is the answer. Okay, so yeah, the second one is the answer. Okay, so let's move on to number 4. Here we're supposed to evaluate this indefinite interval. And again, like I said, products are kind of hard to do. But let's go ahead and distribute this xn. So we have 2x. Now the cube root of x is x to the 1/3. Okay, so I'm going to rewrite that like that. And then plus 7x. Again, I'm distributing the x into here. And then the 4th root of x is x to the 1/4. Now, I'm also going to, this is times here, but it's not a decimal place. So I'm also going to combine these two. So this is like x to the 1st power. 1 plus 1/3 is 4/3. So that's 2x to the 4/3. This one, this is also like 1. So 1 plus 1/4 is 5/4. So 7x to the 5/4. Okay, now that we have these powers, then I can go ahead and take the indefinite interval. So this right here, if I add 1 to that, so what I'll do is you want to add 1 to this. So 4/3 plus 1 is 7/3. Okay, but then you want to multiply by 3/7. Okay, because now when I take the derivative, I have a 7/3 comes down, and that's going to completely cancel that out. And then this reduces by 1 to 4/3, and then this 2 carries up there. Okay, and do the same thing with this one. Add 1 to that, that's going to be 9/4. But I'll need to divide by 9/4. So multiply by 4/9, the reciprocal. So when the 9/4 comes down, then this will cancel it out, and then plus a constant. Okay, so I just need to write this in more simplified form. Let's see, 2 times 3 is 6, so 6/7 x to the 7/3 plus, and then 7 times 4 is 28, 28/9 x to the 9/4 plus a constant. Okay. Oh, wait a minute. Oops, this is a definite interval. So so hold on, I messed up. Let's see here. So let's take out the constant. And because it's a definite integral from 0 to 1, okay, that means that you have this going on. Okay, now this means that you plug in the 1 first, and you subtract and plug in the 0, which is going to be 0 plus 0. So when you plug a 0 in here, it's going to be, this is all going to be 0, this is all going to be 0. So that's what you get there. Okay, so this is 6/7 plus 28/9. And that turns out to be 250 over 63. Okay, let's look at number 5, this indefinite integral. Now, for this one, this absolute value of x is problematic because there's no formula for the antiderivative of the absolute value of x. However, what you should be thinking is that the absolute value of x is just equal to x if x is positive, and it's equal to negative x if x is negative. Okay? And so what you want to do is you want to split this up, this integral up into 2 integrals. Okay, one going from -1 to 0, and then the second one going from 0 to 1. You can do that within any integral. Any integral will split up like this into 2 parts, as long as this works out. Okay, now right here, when you're in this case right here, x is negative. That means that you're going to put a negative x in there. So that will be x minus 6 times negative x dx. Because between -1 and 0, x is negative. So the absolute value is negative x. So you get that. Over here, x is positive. Between 0 and 2, x is positive. So you replace this with an x. Okay? So let me make a note of that. X is negative because in -1 to 0, x is positive in 0 to 1, 0 to 2, I'm sorry, 0 to 2. On this interval, x is positive. On this interval, x is negative. So this x, this absolute value gets replaced with a negative x, and this one gets replaced with a positive x. But it's actually a negative number, so okay. So this becomes x, what is this, plus 6x? That's going to be 7x. And this one, the second one, is x minus 6x. That's going to be negative 5x. Okay, so antiderivative time, 7x squared over 2, evaluated from -1 to 0. And then, let's see, I'm going to pull this negative all the way out. So that's minus 5x squared over 2, evaluated from 0 to 2. Okay, this one first. So that will be 0 minus, and then that. And then here you put with the 2 in, so that's 5 times 2 squared over 2 minus 0. When you put the 0 in, it's just going to be 0. Okay, so we have, this is negative 7 halves, and this is minus, let's see, 2 squared is 4, 4 times 5 is 20, minus 20 halves. So that's negative 27 halves. Would be the answer to that, number 5. Okay, number 6. So the area of the region that lies to the right of the y-axis and to the left of the parabola. So this is the y-axis. To the right of the y-axis, that would be over here. And to the left of the parabola, here's the parabola, that would be right here. So it's this blue region right here. Okay, and they're saying it's given by this integral here. And the reason for that is, like, even though this like looks kind of weird, you know, this is one thing you can do with integrals. You can take an integral in y if you want, if it helps you to find it as this kind of an area. It's much easier than taking in an x. Okay, and basically this is the right boundary and this is the left boundary. So if you take the right boundary, which is this one, and subtract the left boundary, which is y equals 0, well, it's just gonna, you're just gonna get this minus 0, which is this. So this minus 0, which is this. And then you integrate it across the appropriate integral from 0 to 2, 0 to 2, then you're gonna get this region here. Okay, so that's kind of how that works. You don't have to have, so you don't necessarily have to have a region that's defined in terms of where your boundaries are in terms of values of x, functions of x. This is a boundary that's in terms of function of y. Okay, so we'll go ahead and, it just says find the area of the region. So the first part, it's y squared. Take the derivative of y squared, you get 2y, so that's great. And then the antiderivative of this would be y cubed. But you have a 3 coming down, so you can cancel that 3 with the 3 down there. Okay, and then that's going to go, you're going to evaluate that from 0 to 2. So we'll plug the 2 in first. So you get that. So we'll subtract and plug a 0 in. And fortunately, that's just 0, so that's great. That's really great that that's just all going to be 0. So 8 minus 8/3, or let's see, if you multiply this by 3 over 3, then you get 24/3 minus 8/3. That's going to be 16/3. And so that's what there is. It's 16/3. Wait a minute.
I got 4/3 for the answer.
Yeah, something's wrong. So this is, oh, this is 4 right here. What am I doing? So we'll back up. Right there. Okay, we'll back up in time. So this is 4 minus 8/3. And so multiplying by 3 over 3, we get 12 minus 8. Okay, so that's going to be 4/3. Okay, good, great, thanks. Good job. Okay, number 7. If fx is the slope of a trail at a distance x miles from the start of the trail, then what does the integral from 3 to 5 of fx dx represent? Okay, so the start of the trail would be where x is 0. And this is going from 3 to 5 though. So it would be, this is going to be the change in elevation between x equals 3 miles and x equals 5 miles from the start of the trail. Okay, so this is, the distance is measured from the start of the trail. So this would be 3 miles from the start. This would be 5 miles from the start. And that would be the change in elevation. That's what that represents. F is the slope. You know that the derivative of a function is the slope. Okay. So if you have the slope, then that means it's the derivative of the elevation in this case. Okay. So this is derivative of the elevation. Okay, and this also ties in. This ties into the net change theorem, where and you can like, so I mean, this happens. This can also be applied where you have, this could be slope. Okay, and that could be elevation. You know, capital F is the elevation, little f is the slope. I mean, I'm sorry. Capital F would be the elevation, and f prime would be the slope. Okay, so that's how that works right there. Okay, let's move on to number 8. Okay, the acceleration function and the velocity function and the initial velocity are given. Okay, so here's the acceleration, here's the initial velocity. When t equals 0, the velocity is -15. Okay, so like this one says when t equals 0, the velocity is -15. Okay, so let's find the velocity at time t. So we know that the velocity, you know the acceleration is the derivative of the velocity. So we take the antiderivative of this. So the antiderivative of 2t is t squared, and then you have a plus 2t, right? Plus a constant. Okay, now what we're going to do is we're going to use this right here. We're going to plug a -15 in here for velocity. And v is -15 when t is 0. So I'll plug 0 times 0 plus c. And so then all that cancels out, and you have c is -15. So that means you plug this -15 for the c here, and you have the velocity is t squared plus 2t minus 15. Okay, so that will be the answer to that. There's the velocity. And then part B says find the distance traveled during the given time interval. The distance traveled. Okay, this is a quadratic, so that's fortunate. So actually what I'm going to do, and maybe this doesn't make any sense, but I'm going to find out where, I want to find out where, so I guess the first thing I want to do is I want to figure out when is the velocity greater than 0 and when is it less than 0. When's the velocity positive and when is it negative? Okay, because like I said, it could be that it goes one direction and then shifts and goes the other direction. And so if you're trying to find the distance traveled, then that's not going to work too well. It's like you tell someone, okay, run around. Like if you're training and you run around a track 5 times, so you end up at the exact same spot that you started out with. And so if you take the ending point minus the beginning point, that's just going to be 0 and be like, oh, you didn't travel, you didn't cover any distance at all. But in reality, you did, because you ran around 5 times, right? You traveled a lot. You've covered a lot of distance. Okay, so I'm going to try to figure out where the velocity is positive and where it's negative. And so this factors into, 5 and 3. So plus 5 and minus 3. So the places where the velocity is 0 is at -5 and at 3. By given time interval, they mean this, by the way, from 0 to 5. Okay, so in that time interval from 0 to 5, this is out of the time interval, so throw that out. It changes direction when t is 3. Okay. So it actually starts out. Let's see here. So we have 3. Okay, so here we're going to put 0, and we're going to put 3. Oops. 3. So we have t plus 5, t minus 3. So that's a positive times a negative, and they're both positive here. So the product is negative here, and the product is positive here. So this is where the velocity is negative, and this is where the velocity is positive. So that means that the distance traveled will be the integral from 0 to 3, the negative of that interval, because the velocity is negative there, of this, plus the integral from 3 to 5 of the positive part of that, 2t minus 15, of the same thing. Okay, so here the velocity, this is all negative. So when you have this negative out here, this will become a positive number, and it will tell us the distance traveled between 0 and 3. Okay, and because they're all going in the same direction. And then here, the velocity is already positive, so integral from 3 to 5 will give us the distance traveled between the time t equals 3 to t equals 5. Okay, so let's take antiderivative time, t cubed over 3 plus t squared minus 15t from 0 to 3. Now, by the way, you don't have to put a plus a constant in here. And if you did, even if you did put a plus a constant, then when you do the upper limit minus the lower limit, it's just going to be c minus c. So it's just going to cancel out. Okay, and then over here we have same thing, except there's no negative tacked on the front. And that's from 3 to 5. Okay. Well, we're running out of space here. Okay, so I put a 3 in, and you have negative, no, not negative. The negative's right there already. Okay, so put a 3 in, that's going to be 27 over 3 plus 9 minus 15 times 3 is 45. Really? Yeah, that's true. And then you subtract and put a 0, and that's going to be 0. Okay, so don't have to worry about that. Okay, over here you put a 5 in, that's 125 over 3 plus 25 minus, well, it's 15 times 5. 75. But then you have to put the 3 in, subtract and put the 3 in. So that's 27 over 3 plus 9 minus 45. Okay, now I calculated all that out, and I got 137 over 3.